Good news, we are on 3.6 Quadratic Inequalities, which is the last section of Chapter 3. Woohoo! The even better news is you have an opportunity to raise your grade next week sometime with a test.
Yay!
Yay! All right. So, I could probably let you know that right now hey, let me get your attention up here. Right now your chapter test is scheduled for Wednesday of next week. It may be Thursday. It depends how 3.6 goes. So, we'll have a practice test, an actual written practice test, not the online one, in class this time. And I have 2 days for 3.6, but we're starting it a little late today, so we may end up spending a third day on it. We'll see. Okay, quadratic inequalities. Okay, yesterday you're finding quadratic solutions to quadratic systems. Today you have quadratic inequalities and systems of quadratic inequalities. What that implies, and hopefully you're starting to learn the math, inequality means what? Not equal to. You have your greater than, less than, or not equal to signs. Okay? Quadratic means to the second power. When I do a system, what's that mean? You're going to have multiple, in this case, inequalities. So at the beginning here, where it says solve the quadratic inequality, you just have a single inequality. Exploration 2, work with a partner and match the inequality. Well, they don't give any. It's actually on the next page. Okay? And then you move on. From there, you're like, well, there's no systems. Well, the systems come a little later. All right, but it's still in 3.6. We're not going to get to the systems of them today, or much of it. Okay? What I want you to do right now is I want you to work on exploration number 2 with your groupie there. Okay? Let me get your attention back up here. Explain how you can use the graph to solve the inequality. So they've taken this function. Let's take a quick look at what they've done here. They've taken this function. They've now set f of x equal to 0. And then they dropped in this inequality symbol. And they kind of move things around, right? So really what we could do is, if you want, you can think of f of x as being where the 0 is. That helps you to find your intercepts. Correct? That's why we do that. Bless you. Okay? Now, how could we solve it? Well, you could just test points. You're going to either shade inside the parabola or outside of the parabola. Okay? So you could test points. Like the easiest order pair is to test the order pair 0, 0. Okay? Now, if the parabola went through 0, 0, that wouldn't be a good point to test. You'd have to test a different one. But since it doesn't, if we test 0, 0, we get 0. And we get 2 times 0, so really all you're left with is your y-intercept of negative 3. So is negative 3 less than or equal to 0? The answer is yes, so you shade inside the parabola. Okay? Now one thing that I do, and some students like it, some students don't like it. It confuses some, it doesn't confuse. So it's up to you. Okay? You use it if you want. All right, if I think of this function as x squared plus 2x minus 3, and I have the f of x piece here on the end, or if I rewrite it like this, right, either way. You guys with me? Okay, f of x is your y-axis. So this is saying the y values are greater than this function. This expression right here. Everyone with that? Where are your y values greater? Well, if you look at where your function hits the y-axis, which is right there. Everyone understand what I mean? Your y-intercept. Okay? It breaks the y-axis into 2 parts. It breaks it into this part up here. And it breaks it into this part down here. All points on the y-axis above the y-intercept and below the y-intercept. Okay? Which points are greater? are the ones below or above? Above. And that's what it says here. It says it's greater than or equal to. So I'm shading all the points on the y-axis above it. That makes sense? Okay, let me explain it in a different one here. Okay, let's say I have exploration 2. It says match each inequality with the graph of its related quadratic function on the next page, then use the graph to solve the inequality. All right, did anyone match up A already? Yeah? Why don't we look at it really quick. What does it match with? A matches with A. In fact, how can you tell right away? You could. There's an even quicker way. What are these things called in a quadratic? Those are your y-intercepts. And notice in all of these, our y-intercepts on almost all of them are different. These two are the same. Okay, but the only one that has a y-intercept of 2 is graph A. No other graphs there have a y-intercept of 2. Okay? Now this is saying, remember, 0 is the same thing as f of x. This is saying my function is bigger than f of x, or f of x, the f of x values are smaller than my function. So if I look at my y-intercept, where are the values smaller on the y-axis? Above or below the line? They're smaller below, and this is saying f of x is smaller than the function. So my shading goes down the y-axis. So all those points down there, which means I have to shade on the outside of the parabola. Now, could you test 0, 0? Yeah, I mean, it still work, right? If I put 0 here, 0, 0, right? That gets rid of that, it gets rid of that. I'm left with 2 is greater than 0. And that is true. Therefore, you have to shade over the point 0, 0 right there. You have to shade over that point. So you could test 0, 0. If you understand what I'm talking about, you can do that as well. Now, they've made one mistake on this graph, at least for this inequality. What's the mistake? Good. This should be a dashed line, a dotted line, because it doesn't have the equal to piece. Okay? So maybe make a note to yourself that if this is x squared minus 3x plus 2 is less than 0, then this should be a dashed line. Okay. So I want you to go ahead and finish matching those up and shading. I think I can get all those. Oh, maybe I can. Okay. Hey, graph B, or equation B, excuse me, goes with graph. Yeah, it goes with graph C because there's our y-intercept. Okay. So we say x squared minus 4x plus 3, and that's less than or equal to 0, meaning we shade inside or outside the parabola? Inside. If we tested 0, 0 this case, we'd end up with 3 is less than 0, which is not true. Therefore, we can't shade over the point 0, 0. Okay. Equation C has a y-intercept of negative than 0 if we test 0, 0, and that is true. Okay. So we shade inside. All right. Equation D says minus 2. Okay, and this one also says minus 2. Which one? Which graph does D go with? Does it go with this one or this one? It goes with B. Now, how do we figure that out? Did anyone use the vertex on that? Yeah, use the opposite of B over 2A. Okay, very good. So this shades. Negative 2 is greater than 0. That is false. So we shade on the outside. All right. We know equation E goes with letter F. Shade on the inside or outside? We shade on the inside. Okay, if we plugged in 0, 0, you get negative 2 is less than 0, which is true. The last one is D. x squared minus 4 is greater than 0. And that is, negative 4 is greater than 0 is false, so we shade on the outside. All right. Now I think you got it. Would any of these be solid?
Yes, C and B.
C and B are both solid lines because they have the or equal to piece. All the others are dashed. Okay? And so our graphs actually, you might want to make notes. Dashed, dashed, dashed. Okay? All right. Any questions there? Your assignment is to do these two problems on the bottom. Okay? Now, you're going to have to graph these, and I didn't give you grid paper, so hopefully you have some. Hey, really quick. Oh, actually, we'll call it good there.